let's take a bit deep dive into the Spark ecosystem, what exactly it is and things like that. There are so many people who are not from Hadoop background and all. So there would be some of the primers which are supposed to be given. In the first class, we have talked about big data and other stuff. We're not going to spend that much time here. But Spark, which was seen at a very, very high level, now is the time when we'll start, putting some more in-depth time onto it, right? So how it works and all. Again, I'm not putting much of the effort to this. Introduction to big data in Spark. Okay, so the objectives which we are having about it in under. So I would try to cover as much as possible in under some 40 minutes or so about batch processing and real processing. Nowadays, when you talk about batch processing and real-time processing, I am sure if I ask the class, most of you will say yes, we are aware of it, right? But in big data world, they have got a slightly different meaning. They have got slightly different scenario, and the moment you talk about that slightly different thing, the kind of solution which you are trying to put. In fact, so in last class I was having some discussion with some architects and all, wherein the discussion was about that, okay, Vishal, you are telling us that where you should use Spark, but then there might be, 10 different other things where you might not like to use Spark. Right, guys? I hope everybody understands the aspect of it or the implications of it as well, right? That when you should use, you should know, but when you should not use, you should it is equally important as well, right? So we'll see some of those things here. I mean, these kind of discussions are not really written here, but yes, they would come out, right? And then understanding of the Spark ecosystem in a bit more detail. Understanding of MapReduce limitations themselves. So it is very important. I mean, it would be a bit history kind of a thing. The MapReduce limitations, okay, but then it would lead us towards the Spark history. Again, Spark history is something which I don't like to spend more than one specific slide, but the idea would be how Spark is really different from the other, other specialized big data solutions. So we'll come to that part. And then Spark architecture, I would say that probably if I would be able to cover up to history part today, it would be good, and start afresh on Spark architecture, because I don't want architecture thing to go at the time when you are, when our information registers are full, right? So I don't really want to go there, but still. So the objective would be Spark architecture. And then one of the much important buzzwords which are kind of today, doing the rounds, it's about Spark and Hadoop. So people, talk a lot about Spark, Hadoop and all, but you will see that what it takes, what does it mean when you say Spark plus Hadoop? It has got different meanings, okay, depending upon how you are going to use it. So we'll discuss those aspects. And then rather than install Spark, basically here I say that, please refer to the installation document which we have shown. But again, instead of this install Spark, basically I would be spending some time on SBT part of it. Is that, I hope that should be quite clear with everybody, right? See, you are having a huge amount of data. You want to process them using one of the big data systems altogether. Okay. Now, point is, you must have heard about batch processing and real-time processing itself, right? So what exactly are the best examples for it? So guys, batch processing, when you typically talk about it, I would, okay, let me just give you one simple example altogether. Let's say, you are having your retail industry. I'll give you the example of retail industry. You are having your stock ledgers, your general ledgers. They are the typical ledgers which are there in any of the retail industry, I mean retail whatever major you will talk about, even in they are common concepts in the banking industry as well. But let's say in the terms of, this specific retail thing. Now, so what exactly happens on the stock ledger side and all? Those stock ledgers are something which typically have the inventory information altogether, right? With the store, this particular division, this particular item, this many number of overall quantity is available, and the kind of price, and etc. etc. And this stock ledger is something which keeps getting updated every day, right? This what exactly sales have happened, if there are any defects, if there is any theft, and all that, right? So they just keep getting updated, and then at the end of the business day, you have to kind of close your business, and before you start next day's business, all of this has to be consolidated, and your kind of targets, whatever there are any kind of forecasts, financial reporting basically. So if there are any kind of forecasts, or if there are any kinds of targets which you have to set, they have to be updated before the next business day starts. And what is the best way to do that? The best way to do that is take all of the transactions which have happened in a day. You don't really need to do all of this again and again in a day, right? You have to do it once in a day before the next business day starts. And so basically when the today's business day ends and before the next business day starts, right? In between you have to do this process once. Are you all getting the point? Guys, are you all getting this point? So if you talk about this typically that the processing which you would do in this case is once in a day. It's kind of a batch processing altogether, right? Now when you talk about, guys, are you all hearing me? I mean, I'm not really sure whether I'm getting your response or not. Okay, great, yeah, thanks. So your response actually tells me whether it is clear or not, or if there is any question, it can be answered, right? Now, so batch processing is going to be your preferred way. So when you talk about the big data applications and all, it's the preferred way of processing huge amount of data. And typically what happens is you group a lot of transaction over a defined period, right? Where basically it's going to be the frequency of a batch job, once in a day, weekly, or whatever, twice in a day kind of a thing, right? So you'll be collecting that huge amount of data, processing it in a given batch window, right? So batch window means in a whatever that the time period in which the batch runs. So that is typically called a batch window. And Hadoop is the best. So Hadoop is typically used for the batch processing, nothing new. Examples, I think like financial reporting, forecasting, dynamic pricing. Though dynamic pricing in some cases it has become kind of real time as well, but or probably almost real time. I'll come to that when I'll talk about the real time processing, right? So they are typically called the batch processing kind of systems, and we are quite well versed with them, and we are using Hadoop also for them since quite a long time. Not a problem at all, right? Now, if we just move, it's a very generalized kind of way. So you might be having multiple data, sources all together, social data, BI data, operational data, etc., etc., etc. You must be putting them into, your data lake, or if I don't call it as data lake, let's say in a very simple manner, you're just, Hadoop itself, your typical ETL of processes which will be applied, and then you will be doing whatever analytical functions you want to do, right? So good thing, but so what really happens in this case is something like it. Just a second, guys. I don't want to cover real-time processing right now. Okay, I will come back to this slide, guys. I will come back to the slides which I just skipped. Okay, so what really happens in this case? In this case, let's say if you look at about the data, this is your input data, right? Input data kind of timeline, and this is your processing timeline. So assuming that it's a daily process, so whatever is the input data of day 1, that is going to be processed in day 2, and basically it's going to be 1 day delay altogether, right? So all the time, if I'm looking at the data, if I'm looking at some of the report right now, I am quite sure that things have changed, right? So the data which I'm looking right now versus whatever is the actual, whatever should be the actual view it's kind of a stale view, right? I'm not getting a fresh view all the time or hot view all the time, right? It is just that I'm getting some sort of pre-processed data to a certain frequency, which might be a day older, which might be some 2-3 hours older kind of thing, right? Depending upon what is the frequency and all, right? So this is quite good for batch processing, but now let us take a step back. Okay, let us take a step back and talk about real-time processing. Now, when you talk about real-time processing, first of all, before I read any of these points, let me explain that real-time processing is nothing but it's a myth. There is nothing called real-time processing in big data world. Okay, there is absolutely nothing called real-time processing. At max, it is near real-time processing. Okay, so seems like somebody is saying something. Streaming. Again, Satish, these are different ways. I will come to that. You'll realize it is Spark as well. Streaming is big. Okay, but point is, be it streaming, be it Hadoop streaming, be it the streaming way you form, or be it the Spark streaming, all of them are the example or the best examples for near real-time processing. They are not at all the examples of real-time. Let me tell you one of the examples which which I have implemented in one of the banks altogether. But before that, let me just tell a bit more about real-time processing. So real-time processing itself is all about your data processing is gonna continue. Okay, it's not like it's gonna work on a continual input altogether, and it's going to work on those small chunks of the data, and it will keep on outputting the data again and again. So the idea here is, in the batch processing, your applications were running again and again in the larger interval, whereas here the interval itself is going to be very small. Okay, so your program is going to execute again and again, but in the delta time, whatever is the extra amount which came, you immediately process it and show the output. Now, this is the basic difference here. You talk about real-time processing. When you talk about real-time processing here, most of the applications, I mean, you can modify them, but at the very essence, most of these real-time, so-called real-time applications are for the sliding window type of operations. Okay, so most of these are suitable for the sliding window operations altogether. So for example, trending topics in last 1 hour, right? Or trending topics in whatever, last n number of minutes altogether. This is a sliding window kind of operation, right? Wherein right now, probably, I'm just giving an example, okay? So probably up to yesterday night, Modi's, Mr. Narendra Modi's US visit was a trending topic in Facebook, in most of the social media, right? I'm just giving one example. But from 12 o'clock up to, let's say, morning 4 o'clock, there was an incident in India. Some accident happened, or I don't know, some other thing, right? The Shera celebrations and other things, right? So they have just started here itself. So this has become a trending topic altogether, right? So if you look at it, what happened before that was not really a problem. So if you look at from the batch processing perspective, if you had to implement these kind of trending topic algorithms altogether in a batch processing way, probably you might not be getting the latest picture. But if you have to do these sliding window operations, typically you would like to go for something called near real-time processing kind of systems altogether, right? Or if there, let's say there is an event, number of tweets which come on the top of it, right? This is the real-time processing kind of examples. So here the data processing is typically much smaller. It's going to be usually in the fractions of seconds, and as compared to the batch processing, because there the batch window will be at the fastest would be several minutes, right? The typical use case of real-time, or assume that I'm talking about near real-time. Okay, so about the real-time systems would be CEP platforms altogether, complex event processing kind of platforms. So what is the best example of it? Okay, so the best example of it is, though we have not implemented any big data solution for that, it's kind of a cousin of Storm in which I have implemented. It's called Esper. Okay, so what sorry, what happens is, let's say you are doing a transaction. Okay, credit card transaction, simple, and online, let's say you are purchasing something, you provide your credentials, whatever XYZ, and everything is well. You're you are well within your limits. You are buying something, your credentials and everything, whatever you have provided is good, and the transaction happens successfully. Okay, so for example, right now you have done a transaction, very good, everything goes well in the banking world altogether, good. Now let's say 1 hour later, one more transaction happens on your credit card. Okay, credentials and everything is good, okay, again the transaction, next transaction, whatever is happening, again falls within the credit limit, no problems at all, everything is good. Okay, but there is one thing, that the first transaction, the geographical data, which when you agree that okay, I'm ready to share my location, right, and when you are sharing your location, it found that the first transaction originated in Delhi. Okay, but the second transaction 1 hour later is happening somewhere in Mumbai. Right, now it is physically impossible for a person to be there at 2 different places at the same time. Right guys, I hope you are understanding the point, right? So now if this thing has to be detected, right, so even if everything is good, but if the geographical data shows something, now there must be a program. I'm just giving a hint, I mean we have implemented it in that way. Okay, so there must be a program which will continuously run on a stream of data which is coming again and again, right? So, and this program might be somewhere before your request is sent to the payment gateway, right? If that program Boolean returns yes, then send it to the payment gateway. If that program Boolean output is false, then either reject it or send it to something called referral, right? Referral means what would happen in that case, as soon as the transaction would happen, you will get a call on your registered number, okay, saying that sir or ma'am, we are seeing this particular transaction happening right now on your card with this thing. Is this you who is doing the transaction? Has it happened with any of you? Because the bank for which I have implemented is a renowned bank. That would give you the idea as well. So anyway, the process is they are now planning to move it on a larger scale. It was a POC, so not many of you might have got it, but yes, it was implemented for some certain reasons, and then I think it is in the process of Bank of America as well. Might be Satish, right? So there are several, but I'm just sharing my experience, right? Okay, now let me just quickly come back. So those kind of systems are called complex event processing platforms. Now look at it. This the focus point is not really the implementation. The focus point is look at the way you are going to process your transactions. You are interested only in present. You are interested in seeing that, okay, what is this transaction which is coming at, and that's it. You don't really care about what happened in past, what will happen in future, right? There was one program which was written and which was just seeing that, okay, whenever a transaction comes, just look at it, the last transaction and the time and if whatever, right? And then just see that if that is good, otherwise, just send the request for the referral altogether, right? They don't really care about past or they don't really care about the future. That is the basic difference altogether of the real-time processing systems altogether, right? So though I have not covered this part, okay, I'm not trying to confuse you here. It's all about you will be having multiple data platforms, then there would be a shared metadata kind of a layer. These are typical ways, okay, these are typical ways in which, you know, you create your real-time systems, and then your small real-time systems would just be working on this data, shared metadata altogether. They would be working, and then they would be generating some sort of notifications. Okay, so most of the times your real-time systems or so-called real-time systems are used for the event processing or for the event notification, and not really any processing. So any processing, when you talk about the processing of calling you, confirming the things and all, happened by some other bank enterprise system, right? Your real-time enterprises, your real-time you know, big data system didn't do anything. Are you getting my point? Your real-time big data application didn't do anything other than passing the request to the right person, passing the request to the right application altogether, and that's it. Its scope is over. Is that clear to everybody? The basic difference, the way you should go for your problems, right? And also it's called real time also because there is no point of saying that this was a fraud transaction when the transaction has happened, right? All of the referral has to happen before your request goes to the payment gateway, right? All of this. So that's why people call it as a real-time system, right? So these are some of the things where you have to think. So when you are going to apply Spark, right? Spark in some cases can be used for real-time processing, but most of the places its typical use case is going to be very fast batch processing. Okay, so I would give you another best example for which we are kind of, so there are two POCs. One is in the, we are about to productionalize it, and another one is in the POC stage, wherein we are just trying to enhance it a bit more. So one is called dynamic pricing. I am sure I'm not going to spend much time on the dynamic pricing. It's all about, you know, that depending upon the demand, your inventory, you know, prices have to be dynamic. They have to change very, very fast. Okay, so that was the place wherein we have applied Spark processes, and they have kind of, you know, so now basically this retailer, I can't name it right now, but this retailer has now applied this dynamic pricing module, and it runs kind of every half an hour. Earlier it used to run once in a day, and then when it went to Hadoop, it was running thrice in a day. Okay, but now with that it is running every half an hour, and they are able to get much better responses or much better margins altogether. Okay, so this is just one example. I'm just giving you one example about the suitability. See, more than the language itself or more than the framework itself, these kind of questions will come to you when you will be implementing these. Should I implement, or is this the best fit, right? So just keep these things in your mind, and that's why this entire discussion, one-time discussion, is happening with you. Okay, so Hadoop for batch processing, I'm not spending much time on it. It's about so the overall purpose of keeping it here only is for those people who are not aware of Hadoop, right? There are several here. So HDFS, it's the storage layer, and we have covered only Hadoop 2.0. We are not showing Hadoop 1.0 because that's the way forward, right? Yarn, that's your cluster resource management, and then you have MapReduce framework on the top of which, you know, Pig and Hive can run, and then you have other Yarn frameworks, right, which are like your Giraffe, your Spark, right, and there are several others as well, Pregel, Dremel, etc., which can run on the top of it. And then you have HBase, which kind of, you know, directly interacts with HDFS without Yarn, and this remains unchanged till now as well, right? So this is something wherein your typical, you know, the Hadoop ecosystem is, and on the top of it you are seeing UC. It's all about your workflow scheduler. So in a job you might do some sort of scoop and then do some sort of pig processing and probably you know, persisting some data into HBase and then doing some kind of fetching it, right, into, let's say, a UI. You want to do these things in one by one order, and if there is any failure, you want some sort of decision points, etc. Those are some of the things which you can do in workflow scheduler, which is UC, right? So I'm not spending much time into it. I hope everybody understands it, right? Great. Now, so again, some of the Hadoop key characteristics and all, which are quite clear, and those people from Hadoop classes must be able to recognize them as well, right? So quickly, it is about scalability. So again, since it's a Hadoop cluster of commodity hardware we are talking about, scalability is something which you already get. Economical, of course, because you're talking about the commodity hardware, which is of course going to be more economical as compared to industry grade, those big servers and all, right? And reliability side, so which is built in within Hadoop. So it's really good for your batch processing itself. If there are any failures, auto scheduling it, speculative execution, and auto replication altogether. So some of those things. And when it comes to flexible, it's quite flexible. And so when we talk about it, you can either deal with the structured data, unstructured data, semi-structured data, etc. So these are the typical Hadoop features. By the way, there is a reason of spending even those, we have chosen very, picked and chosen very specific slides for it. Okay, there is a reason behind it. You will be very, very clear about it when we will come to Spark plus Hadoop. Okay, so that's the direction in which we'll move. I hope data processing in Hadoop is quite clear to everybody, right? Basically, I just wanted to show you this is a batch processing system. It is all good, but the problem for you is that 1 day delay kind of a thing, right? So it typically leads to the time lag, and this is where basically Spark comes in between. Spark overcomes this time lag issue. So I'm not saying this time lag is going to be 0, no, but this time lag is going to be much more manageable, because there are some of the timelines which are acceptable to the business, and then there are some which are not, right? So in many cases we have seen, as of now I have implemented 3 projects in Spark. When I say 3 projects, it means at the organization level, and one of them is going into production, one is in POC, and another one is kind of in the ideation stage, kind of. Okay, so Sridhar says, when you say Spark plus Hadoop, is it integration of Spark with Hadoop? Yes, Sridhar. Okay, Spark, again, this is again the slide which you must have seen earlier, I'm sure. I hope everybody is able to recall. So I don't really want to spend much time on this slide, or unless somebody wants me. It's about, I had spent quite a lot of time when I told you that it is a general purpose cluster computing system. If you just look at this, it is Hadoop, right? General purpose cluster computing system. But when you put in memory, then it becomes Spark. So it's a general purpose cluster in memory computing system. The computations happen in memory rather than streaming the data from the disk itself. Is that clear? And it is used for fast data analytics, blah, 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 whatever about these high level tools and all. These are some of the things I am sure you are able to recall. Does anybody need any explanation on any point here? If not, I'm moving to the, some more important parts. Okay, so spelling mistake. It is BlinkDB, guys. I'm so sorry. Okay, I have to inform the support team. It should be BlinkDB. It is not BlindDB. Okay, so now this is Spark ecosystem, and you can see that many of these releases are in alpha or pre-alpha releases. It means they are not even available for kind of exploring. So Spark is not available. Graphics is almost unusable. It's kind of, they have recently released an alpha release, but it's a bit unstable with the latest one. The things which are kind of okay are Spark core engine. Yes, it works. You can write your core Spark programs, very good. MLlib, there are some of the things which have just come up, okay, and you have the Shark, which is basically you'll be using for, again, I've covered these things, that's why I'm not spending that much time right now. It's about, Shark SQL for the SQL thing, Spark SQL. So Shark/Spark SQL, you can say that. Shark is something which is full-fledged available. Spark SQL is something which will be available after, sometime in the full-fledged manner. Right now it's about, you can expose some of the documents as in the form of some tables, but not really the Hive tables as such. Okay, and then you have Spark streaming. We'll be seeing that example. Spark streaming, AMPLab. So instead of spending time on AMPLab, I have kind of created, I'm not really sure, it is somewhere in between of the first batch and the second batch. I am trying to create my own machine learning small kind of, experiment, and I'm somewhere in between, guys. I'm not really sure how to complete it and all. It is somewhere in between, but yes, it's about how to perform data visualization using Spark. I'm working on that. So if you have some data, how do you, approach about it? How do you really show in the form of graphs and all? Will it be exciting for you to look at it? Does it excite you enough? Or it's like, okay, we can look at it later or something like that? Because I'm planning to show it in the class. That's kind of the advanced stuff which I'm just trying to achieve. Okay, and since, great, and since when it comes to the, graphing and other stuff, our Spark is not yet available, and Scala does not have a really good, histogram and other capabilities. So I'm using Python for it. Okay, so just for that, I'll be sharing whatever I have done, that entire source code and data also with you people. But still, you can take it forward. It's kind of, I have to do some more work, and then it will become an application itself. Okay, so I'll be trying to show you some of those aspects in the last class. Okay, so again, when it comes to the Spark ecosystem, again, this is something which is already well discussed, right? So Shark is basically Shark or Spark SQL for SQL kind of analysis, and they are typically called data science tools, right? So you want to perform some sort of ad hoc analysis, you would like to use Shark or Spark SQL or even BlinkDB whenever it will be available, right? But if you are more of a developer kind of a person, right, your job profile is more of a developer kind of a thing, then you would typically like to go for Spark core engine, use Spark streaming, or AMPLab when it will become mature and all, right? So these are some of the things which you will be using. And in fact, guys, since Spark is a very fast moving community, in further some more iterations, you will see some of the new modules which will be added. Okay, this is my plan, to add some new modules as and when these new things will become available. So, and anyway, since you have the LMS access for lifetime, you will be seeing those additional things for yourself. So it's just a request, keep watching them. Okay, once the course is over, at least whatever will be the updated version or material, it will be available, I think, with the recordings also. Okay, so not spending time on Spark ecosystem, guys. This is just for your revision, right? Bit more details about, basically there are some other aspects which I want to cover. Is everybody okay with it? Spark core engine, Spark SQL, Shark, we have already discussed this. Right, guys? AMPLab, graphics, Spark R, what exactly they are, right? So I'm not spending the time on it. I'm spending the time on which is important. Okay. Now, this was kind of, just in case if you have forgotten. Guys, there are some important things about why exactly we should go for Spark and all again. So these are, apart from that Spark ecosystem is providing you various tools to do the things, there are some of the things which are important or which are peculiar about Spark. One is it provides you a very simple programming layer, right? But it's not just a programming layer, it's about its caching capabilities and disk persistence capabilities. You will see that when I'll talk about RDDs, right? Resilient distributed data sets. When I'll talk about that, you will see these aspects in action. Okay, so caching capabilities, you can cache the results if they are more than this much, more than a certain number, whatever is, or more than a certain limit, then you can either persist them in disk fully, partially, up to a certain factor and things like that. Okay, so there are some of the factors which are available. And other thing is, Spark is something which is not a very tightly bounded kind of a system. So if you have, let's say, your own, basically you are running Spark in a standalone mode, right? No other cluster manager, it has got its own cluster manager. But otherwise, you can integrate it with Yarn, which I will cover in the class, and with Mesos as well. Mesos is something which we do not cover, but yes, it can be, integrated with it as well. Okay, it's polyglot. I have just told you. Scala, you have just seen. Python, you can write the programs in Python as well, and Java also. Okay, it has got a super active community and all, completely okay. It fits well with existing Hadoop ecosystem. Now guys, this is very important. Can you look at this second point before the first one? The second point, which says it can fetch the data from Hadoop 1.0, right? This is very important. Many times I've talked about it, and I've talked to many people. They say that, okay, if you have to use a Spark with Hadoop, you have to use Hadoop 2.0. Okay, you have to use it with Hadoop 2.0. No, here it can fetch the data from Hadoop 1.0 itself. But remember, you are just fetching the data. You are using Hadoop as the storage. You are not using Hadoop as a cluster manager. If you are using Hadoop as a cluster manager, then the first line is very important. It can be launched in the existing Yarn cluster itself, okay, if you really want to use it. And of course, it can be integrated with Hive. Of course, in the bracket, it goes without saying that right now using Shark, in future using Spark SQL as well. Okay, so this is how it fits into it. By the way, as my experience says, most of the times it would be the second use case wherein you would like to use it. You would like to leverage Hadoop's storage power more than its processing power. Okay, we'll come to that. Okay, Lakshman says something. I had a very bad experience with in-memory tools, ClickView. Okay, when RAM maxed out. I'm not sure how Spark handles it. Yeah, Lakshman, I'm coming to that part. Okay, so just a second. Let me see how much we can cover. In fact, we are already at 10:15. Okay. So Lakshman, just to give you an answer, see this. Okay, so this is the execution time, and this is the percentage of working data set in the cache. If you fully cache it, this is going to be your response time. Let's say 12 seconds or 12 milliseconds kind of thing. And if your cache is disabled, this is going to be 69. In between, it's a graceful degradation. I'll cover that more in the next class, tomorrow's class. Right, Lakshman? But it should just give you an idea about it, right? So guys, I think I should not extend it more, any further. I'll just cover this slide number 21, and then we'll just continue on the things tomorrow, right? So about history, again, it's just a theoretical point. I'm not spending much time because you can read it. The point which I want to say is 2002, you had MapReduce, paper published. And then 2006 or somewhere around 2008 early, okay, MapReduce or that entire Hadoop thing became the part of Apache. It became a top level Apache project. It took 6 years. It took 6 years, which is kind of a de facto standard, right? I hope everybody understands it. 2010, Spark paper got published. It just got published. 2012, it was actually adopted. It was adopted means its first implementation came out. First implementation came out in 2012. Okay, and it was not adopted by Apache. And it was 2012 late or 2013 early, I've just forgotten, when it got adopted by Apache as an incubator project. Okay, we are just talking only 1 year earlier, kind of 1.5 years earlier. Okay, and right now it has become top level Apache project. Just look at this is the project which is the fastest to achieve top level status in Apache. Okay, and it is coming up big time. Why? Why? It is not just that everybody has heard about Spark and everybody is putting the effort, right? Cloudera is betting big on it. Hortonworks is now betting big on it, right? For a reason, right? So for those reasons, right, Devendra, exactly. So Devendra, the question which you have asked, right, how do Spark and Storm compare? All I would say is, you will get the answers from these slides. Slide number 22, 23, 24, and 25. Basically up to slide number 26. Okay, 22 to 26 have the answers for your question. Okay, Devendra, I'll remember your question. You will get the answer. If you don't, then I will tell you. Okay. So guys, I think yes, this is where it is. I hope it is good to give a logical break, and see you then tomorrow. And I hope you liked it. We made quite a good of progress. I mean, if you see, it is slide number 21 where we are. It's not really slide numbers which matter to us, right? Because there would be 2 or 3 slides which would be taking a lot of time, and then there would be some of the slides which wherein you can just pass them through, right? So tomorrow the session, when it would start, there would be some serious topics about it, right? That how Spark is different. As Devendra was asking question, Storm versus Spark, right? When not to use Spark, right? So these kind of things would come up, and then immediately after that, since it's theory, I just want to finish it fast, and then I want to spend more time on the hands-on SBT and then the baby steps of Spark. Okay. So Kalpana, just to avoid those within class people try to follow, and then sometimes people don't have a good connection, some people get it delayed and all. That's the reason due to which we have created the installation manual. Okay, that installation manual gives screenshot by screenshot steps. Okay, but if you get stuck at any point, you can come back to me, I can answer. Okay, Kalpana, so you are supposed to do it. I'll still try to go through them, not a problem. And you had a question, so I will. Yes, definitely. Helpdesk will help in the installation, and I think they must have helped 1 or 2 people. They will remotely log in and help, right? Sridhar, they must have helped you, right? Or somebody else, I don't know. Okay, so they have helped Sridhar. Kalpana. Guys, do provide your feedback. That is equally important for us, please. Okay, so I always request for it because it gives me the chance to see if there is anybody whose specific concerns are there which I can improve for that particular person. Okay, did you get, so Raj, I didn't really get a chance to look at it. I saw one mail from Raj. Okay, so I think it was you. I'll just check it, or I'll just ask the support team to get in touch with you. Okay, and don't worry, it will solve. Okay, sure. So Kalpana, you want to ask the question now? Probably you had some question which I said that I'll be taking later, right? Others, if you don't have a specific question, yes, I think we can discuss for the day, and you can please do provide your feedback, guys. That's all I just want to say. Okay, Kalpana, you want to come on there? I won't be coming tomorrow due to personal reasons, but would go. Thanks, Raj. Sure, and I do request you to go through them. Sure. Thanks for informing upfront. Okay, Kalpana, you want to come on there and ask? We could take it offline. Sure. Sure, not a problem. So you can just drop a mail with your question or whatever way you want. Okay. Okay, then see you tomorrow, and yeah, look forward for your feedbacks, guys. Bye. Bye for now.